As you can see, this is the inside of the driver, or the motor or motion controller. These are the stepper drivers. As you can see, they're pretty small. And this is the one that's blown up, and it happened to be the one that was at the end on the y-axis. So I suspect that it got glitched by the plasma cutter. So I'm going to have to keep the lines as far away, which is probably pretty obvious. I think a lot of people would agree with that. So I'm going to take this apart. I've got another spare. I'll put it on there. I'm going to add some extra long lines to the other unit and or the other motors, because I'm just doing some testing with the old little motors there. But in any case, so I'll replace this one, and we'll try and get a little bit better isolation, and hopefully that'll alleviate having that problem again. It might explain why it glitched so quickly, is that if it was sending a big spike down to this driver, it was feeding back into the computer, and probably if it didn't damage it, it certainly, like, threw it for a loop. It seems to be working okay now, except on this channel, and it was visibly dimmer light on that location. Yeah, you can see it's dimming out. The other one seems quite bright. You can see those two seem quite bright, and that one seems quite dim. I measured the output voltage on, it's got an internal regulator right here. Whoa, that's very, very hot. It's got an internal voltage regulator, and the output voltage on it is pretty much 0 volts. So clearly, yeah, these ones are not hot. So clearly there's a problem here. Something has died on that board. So I'm going to take it out, do a little post-mortem on it if I can, but it's all surface mount components. I can show you the other one here. This is one of my spares, and as you can see, there's not going to be a lot you can do with it. There's really only 2 semiconductors on this board that are obvious, and that's the voltage regulator here and the main controller right here. So if anything blew up, it was this, the main control chip. I'm not focusing very well there. It was the main control chip on here. I'm not being very cautious. I really should be using static precautions, but these seemed, they seemed pretty durable up until now. Anyways, guys, we'll probably post this video tomorrow. Okay, so the project's on hold for a little while here. This is the new board, but I had some bad luck, and I actually ended up burning some of the traces off of the board when I was trying to solder to it. I tried to make a patch, but it isn't going to work. So I'm waiting for some new driver boards. I'd actually ordered them on Wednesday, and there's a chance they might come today, but in all likelihood they're probably not going to come till next week. They're heavier duty versions of these boards. These are called Big Easy drivers, and I had no problem with them. They seem to work well enough, but if I was going to do it again, I would have, instead of soldering wires directly to the terminals, I would have mounted some header pins and had them plug into sockets, and it would have been a lot easier to replace. And not only that, the likelihood of me, desoldering wires from them and resoldering them and burning traces off would have been a lot less. Well, it would have been 0. But in any case, so this is on hold for at least a little while. I was just trying some different things. I was changing these from it's actually 1/8 stepping to full steps, and just so you understand what that means is that normally with these little stepper motors here, they turn a discrete number of steps per revolution. These ones are 200 steps per revolution. What they do is, if you actually have one in your hand, you can actually feel the detents in them, and what there's I can't remember if it's called an armature or stator. My motor theory from university is long gone, but basically it's like a splined shaft, and there'd be 200 splines around the edge, and you have 4 wires coming in controlling 2 magnets, and basically by selectively energizing the magnets, you make it turn like a slight amount. There's some pretty good explanations on the web, so take those ones for under advisement. But in any case, what these boards are capable of doing is, if you do full step, it just 200 pulses to the board makes the motor turn, you know, one full revolution for a 200 stepper motor. These boards are capable of what's called a half, quarter, and eighth stepping, and eighth stepping is the default. So it means that they actually can flake out the motor, so it'll actually have 8 more discrete positions in between the, you know, a normal step. Problem with that is that you lose a lot of torque doing that. So I was going to try and change these to do full stepping to see how much it would improve, but unfortunately, you know, I damaged my spare board, and so that's not going to happen. In any case, take it under advisement. You know, don't solder directly to the little boards. The new boards are bigger, capable of about 2 to 3 times the current capacity of these ones, and they also have screw-in terminals that I can solder onto the boards rather than this stuff. So they will be a hell of a lot easier to work with than these. Anyways, later guys.